Hi guys, welcome to this, the fifth, I think, video in our series looking at the atmosphere, and in today's video we're going to be looking at the Itcz, or the Intertropical Convergence Zone. Now, the Intertropical Convergence Zone is a band of air that goes all the way around the Earth. It is characterised by extremely heavy rain, and the movement of this zone happens throughout the year as it's driven by the thermal equator. Now, what we're going to be looking at in today's video is the impact that the Itcz has over Africa. So first we've got this image here, which is just to give you an idea of the extent of movement that we can have with the thermal equator over the course of the year. So if we look, at the kind of September-March equinoxes, we've got the, pardon me guys, we've got the thermal equator is more or less directly over the actual equator. As we move through the year into June, and we go into summer in the northern hemisphere, the thermal equator drifts north, and it's driven by seasonality, the shape of the Earth and its angle in space. As we then move further through the year, that equator then starts to drop south. So we can see here, March, we have been on the equator, we've went through into June, we've moved north to around about the Tropic of Cancer. As we come south, back into September, we're at the equator again, through to December, we're down towards the Tropic of Capricorn, and it returns. And this just happens, every single year it's constantly moving. What we sometimes see are diagrams like this, where it gives us an idea of what the thermal equator actually looks like at different points of the year. Now, what we are going to be looking at, what we're going to be talking about, is a variety of a couple of things. So we've got air masses. We need to think about what the tropical part of these air masses is, and then there's maritime and continental added into the air masses as well. When we're talking about them, we need to talk about where these air masses are from, where they're moving, are they stable or unstable, and what are they like in terms of the weather conditions there. So you can see in the little diagram that I've got in the top left that we've largely got two air masses that are jostling kind of for dominance over Africa. We've got a tropical continental air mass in the north, and we've got a tropical maritime one in the south. Now the tropical continental air mass, first by tropical, we just mean that it's warm. So it's a warm air mass, both air masses are warm. By it being continental, we're talking about the fact that it's very, very dry, there's very little moisture in that air mass. And then flipping that, when we talk about the tropical maritime one, again it's tropical, so it's warm. And when we're talking about that it's maritime, we're getting at the fact that it's very wet. Now to look at some of these kind of bullet points I've got here for each of these air masses, our tropical continental air mass develops over the Sahara. Now that should give us an idea of what it is we're actually talking about in terms of weather conditions. It's very, very hot. It's very, very dry. It is a desert air mass. It moves gradually south as we go into the kind of the later parts of the year, and the Itcz is at its maximum extent south. It's a very, very stable air mass. You've got high air pressure. Again, we're talking about this being influenced by the falling air that comes from the kind of tail end of the Hadley cell that we've talked about earlier. So it gives us some very, very stable air. And I've already mentioned, in terms of temperature and moisture characteristics, it's very, very warm and very, very dry. Our tropical maritime air mass is kind of sourced over the mid-South Atlantic, where it develops. And it gradually moves north as we go into the kind of the middle of the year, and as the Itcz moves north. This is a reasonably unstable air mass. This is an area that's predominated by a lot of low air pressure. Again, we're talking about rising air as it's being heated and it's evaporating. So we get a lot of convective or convectional rainfall in this area. So it's reasonably unstable. Then again, temperature, moisture characteristics, it's very, very warm, but this one is very, very wet. So what we're going to do now, that's a kind of an overview of what are the main air masses at play. And if you're discussing this in the exam, you would be expected to talk through the points that I was just going through. Basically, if you can answer the bullet points in this slide, you can talk through enough for the exam, for at least the start of this answer. Now, as we move through the year, so we start in January, this is what our Itcz looks like. It is, more or less as southerly as it's going to get. And we've got rain located over the kind of the thicker blue line that's on the diagram. So we've got a lot of rain, particularly over the Tropic of Capricorn. And everything north of the ITCZ is very, very dry. The air, as we say, is very stable, but it's based out of the Sahara, so it doesn't bring much moisture. We also get, and I'll be sure to put this up in class when we talk about it for spelling, but we also get a band of winds that travel in the direction that the diagram showing you here, that's kind of blowing down this way. And in this context, we call them Harmahatan winds. And it's just a name for a very, very dry wind that comes off the Sahara. Now, we move through the year. We're going to March. The thermal equator has moved north. The ITCZ has moved north with it. So we've got a lot of rain over the actual equator, 0 degrees. Everything south of the ITCZ will be reasonably wet. This marine air is still unstable. Everything north of it is still dry because the band of rain, the ITCZ, hasn't made its way there yet. We move into July. We are at our maximum northern extent. So again, the ITCZ is about as high up as it's going to get, and we're going to get rain falling over the Tropic of Cancer. Now, you will still get rainfall, further down, where this wet maritime air mass is, but you won't get quite as much as where the ITCZ actually is. It's worth noting as well, however, that the areas up at the most northern extent of the ITCZ aren't getting as much rainfall as the areas down here did earlier on in the year. And the reason for that is once the ITCZ leaves the South Atlantic and it's over mainland Africa, it doesn't have an available body of water to evaporate more moisture from, so it does run out of rain eventually. Now, particularly, to follow on from that point, particularly as we move on into September and it starts to transition south again, we see that these areas, some of them, will get another little kind of peak of rainfall as it comes back over, but it certainly won't be as much rainfall as they got when the ITCZ passed north first time round. And that then brings us back to January, and the ITCZ has moved back to its most southerly extent. It'll also be recharging in moisture from the South Atlantic that it'll be now back over. And that's how the ITCZ works, or the ITCZ. I've mixed and matched ITCZ and Z, it really doesn't matter. One thing I've thrown in at the end of this is the kind of thing that you would really expect to see in the exam. Now, it's a really, really common question. It's a really common format for this question to take. And if you can't read this slide terribly well, let me know in class and we can have a look at some of the actual, real examples. So, it's saying, describe and explain the varying rainfall patterns shown in reference diagram Q1b. And then you've got a couple of different diagrams. Now, one thing I would say, this is an older example of this question. So now you wouldn't get a describe and explain. It would tend to just say explain, even though it'll expect you to do the description anyway. What it's going to say is, explain the varying rainfall patterns shown in, then it'll probably give you some diagrams. What you need to do for this type of question is the stuff that I've been talking about already earlier in the video. So first, you need to look at your rainfall graphs. Describe where is the peak rainfall for each region, when does it occur, and what value is it. And you can approximate the values. Sometimes these graphs aren't brilliant at being particularly detailed. So you do that for maxes and minimums. You're then looking for what extent of rainfall is there. Is it something like Lagos here, where it has got rainfall literally all year? Or is it like Timbuktu, where we have got very clearly a small wet season and the remainder of the year is extremely dry? We then also look to see how many peaks of rainfall do we get. So Lagos gets 2 peaks. So it gets its first peak in June, and that's when the ITCZ passes over for the first time, where it's kind of crossing the equator and it's starting to move north. So we've got a peak of rainfall then. And then as the ITCZ returns and it passes again on its way south, Lagos gets a secondary peak. Now, Jos and Timbuktu don't get that secondary peak. And the reason they don't get a secondary peak is because as the ITCZ's passing back over them, it's not had a chance to replenish any moisture. It's not had a chance to evaporate any fresh moisture from from the South Atlantic, like the ITCZ will have had by the time it gets to Lagos. You move on into that, and we're then going to need to match up what's happening with the ITCZ. So we're going to talk about the fact that we've got two air masses. One of them's very dry, one of them's very wet. The reason we've got a dry air mass is because it's formed over the Sahara Desert. The reason we've got a wet air mass is because it's formed over the South Atlantic. We match up our peak rainfalls with when the ITCZ will be over each of these areas. And you'll tend to get a guide with a map that will give you, the degrees that we're talking about. So, 20 degrees north is about as far north as the ITCZ goes. It can go a little further north than that, but you get the idea. That's about as high as it's going to reach. And then last, why is the ITCZ moving at all? So you're expected to be able to discuss what is the thermal equator and why does it move throughout the year. So the core parts of that, remember, we can go back and look at the stuff that we have that shows us how solar insolation varies with latitude. And one of the parts that we looked at there was seasonality. And that's what we would bring in here. Now, I'm going to wrap this one up here, guys. We'll talk more about the ITCZ in class this week. Apologies that this video is going up a wee bit later. I've just not had a chance to upload anything before now. And we'll have one video left in atmosphere when we're going to look at a couple of different odds and ends. We'll talk about thermohaline circulation in the oceans. And we'll look at Rossby waves as well. And until then, guys, I will catch up with you later. Bye.